Hi everyone and welcome back to Matthew Wister. Today we're going to be covering a chemistry Regents review on electrical and intermolecular forces. So to start off, we're going to read this cluster, this chunk, and we're going to break it down into the specific keywords in science that we know. So to reduce carbon emissions in commercial aviation, researchers are synthesizing sustainable aviation fuel from bio-based alcohols. So the bio-based alcohols is what right now is being measured in this table. A major phase of this process involves separating pure organic fuel components from byproducts based on their bulk scale physical properties. Bulk scale physical properties, these are just physical properties, right, that we can see on a macroscopic scale. So it's not microscopic where you can not see it with the naked eye. These are properties that we can see, that we can measure. 3 liquid compounds isolated during the refining stage are methanol, ethanol, and propanol. At room temperature, these liquids exhibit different behaviors due to the nature of the attractions holding their particles together. What this means, the nature of the attraction, is intermolecular forces or electrical forces. These are the same thing. Now, these forces are what's holding the molecules together, the attractive forces. To investigate how molecular structure influences these macroscopic behaviors, an engineering team measures the vapor pressure and boiling points of these 3 pure liquids at standard atmospheric pressure. The experimental data is recorded in the table below. So let's talk about vapor pressure and boiling point up here. So vapor pressure is the measure of a substance's tendency to evaporate into a gaseous state. So if we were to have a lower vapor pressure, that would mean that in a closed container, these vapor molecules aren't escaping or trying to evaporate into a gaseous state as easily. But if we have a higher vapor pressure, that means that it does evaporate more easily. So it has a higher tendency to evaporate in a closed container. But now boiling point, I'm going to write over this. Oh, I can't write over there. But now here we're talking about boiling point. Boiling point is just the specific temperature that you need to raise a substance to in order for it to start boiling, in order for the molecules to start separating and therefore evaporating. So if we had a higher boiling point, that means that we need a higher temperature in order for the substance to start boiling. So we need to put even more energy. That means that it's not going to start boiling as quickly. So there's more energy needed in order for the molecules to start separating. But now if we have a lower boiling point, that means that we only need a little bit of energy in order for the molecules to start separating. So it's going to start evaporating more easily or boiling more easily. So now let's look at the table here. So we have methanol, ethanol, propanol, the boiling points, and the vapor pressure. So just to do a quick annotation, we can see that the boiling point is increasing down a column, and we can see that the vapor pressure is decreasing down the column. So now let's look at the question. Which statement describes the pattern in vapor pressure for these alcohols at 20 degrees Celsius? So the vapor pressure, as we noted here, it's decreasing. So we can immediately cross out B because vapor pressure is not increasing. We can eliminate C because it's not staying constant. We can eliminate D because it's saying that the vapor pressure is directly proportional to the Celsius temperature. But that's not the case here, because the Celsius temperature is staying the same. It's staying at 20 degrees Celsius. But let me just explain why A is correct. It says the vapor pressure is decreasing, so that is true, as the size of the molecule increases. But how do we measure the size of the molecule? We can do that by counting the number of atoms in the compound. So we see methanol. So in methanol, we have 1 carbon atom, we have 4 hydrogen atoms, and we have 1 oxygen atom. So we have 4, 5, 6 atoms total in this compound. Then for ethanol, we have 2 carbon, we have 6 hydrogen, and we have 1 oxygen. So we have 6, 7, 8, 9. And then for propanol, we have 3 carbon, we have 8 hydrogen, and we have 1 oxygen. So we have 8, 9, 10, 11, and 12. So we can see that the mass is increasing as we go down the column. So if we were to look at the relationship, the vapor pressure decreases, yes, as the size of the molecule increases. And that is also true. So A would be your answer. Now we have the next question. Based on the provided data, which compound possesses the strongest electrical forces holding its particles together? So again, strongest electrical forces, that's just the intermolecular forces. So in order to determine how strong the electrical forces are, we can look at the boiling point and the vapor pressure. So as we talked about earlier, if it has a higher boiling point, it needs more energy in order for the molecules to start separating, for it to start evaporating. So if we look here, which one has the highest boiling point? Well, that's propanol. So I'll just mark that down for now. And we also see that propanol has the lowest vapor pressure. So since propanol has the highest boiling point, that means that we need to use a lot of heat in order to get propanol to start boiling, in order for the molecules to start separating. And because we need a lot of energy to get the molecules to start separating, that means that the intermolecular forces holding the molecules together is already strong, because it takes a lot of energy in order to get them to separate in the first place. And also, since the vapor pressure is the lowest, that means that it has a lower tendency in order for the molecules to evaporate. So, since it has the lowest tendency, that means that the forces holding the molecules together is stronger. Now to the next question. A technician claims that because methanol has the lowest boiling point, it must have the weakest electrical forces between its molecules. Well, as we see here, methanol does have the lowest boiling point of 64.7. And this technician is claiming that it must have the weakest electrical forces. Now, I'm going to support the technician's claim. Why? Because just like we talked about earlier, a lower boiling point means that you only need less energy in order to get the molecules to start separating. And if you only need just a little bit of energy in order to get the molecules to start separating right away, that means that the forces holding these molecules together isn't that strong in order to keep it together. So we can say that a lower boiling point means that we need less thermal energy in order to overcome the attractions between the particles. So it means that methanol has the weakest electrical forces between its particles. Moving on. Describe the relationship between the strength of the electrical forces between these liquid particles and their measured vapor pressure at 20 degrees Celsius. So what this is asking us is to write a relationship, or the cause and effect relationship between intermolecular forces and its effect on vapor pressure. The stronger the electrical forces, the lower the vapor pressure. Because again, a lower vapor pressure indicates that the molecules have a lower tendency to escape, to vaporize. And that means that the attractive forces holding these molecules together is stronger. Moving on. The engineers expand their investigation to optimize distillation columns. They introduced a fourth compound, butane, which is a nonpolar hydrocarbon byproduct. They observed that even though butane has a larger molar mass than methanol, butane gasifies much more readily, possessing a boiling point of negative 0.5 degrees Celsius. Identify the independent variable, which is what we're manipulating, when transitioning from the initial investigation of alcohols to the observation of butane. Well, the thing that we're changing is the type of substance or molecules that were being tested itself, because we're going from measuring alcohols in our initial investigation to then measuring butane, which is a nonpolar hydrocarbon byproduct. So what we're changing is the type of substance or molecule being tested, because we're going from alcohol to a hydrocarbon byproduct. Next question. Based on the chemical structures and bulk scale properties provided, explain why butane has a significantly lower boiling point than methanol despite its larger molecular size. The reason why butane has a lower boiling point than methanol is because it has weaker intermolecular forces that are keeping the molecules together from separating. So butane has weaker intermolecular forces than methanol, so it boils at a lower temperature and thus vaporizes more easily.